In this video, we're going to look at summing a finite series using the method of differences. The first part of this is a bit sort of theory heavy, and I don't really feel it's 100% necessary. But essentially what we have, if we have some series, and we'll call that series u sub r, and the series can be expressed as the f of r minus the f of r plus 1, what we can do when we sum this series, and we will sum from r equals 1 to n of u sub r, we can now set this equal to the sum of r equals 1 to n of the f of r minus the f of r plus 1. So if it can be expressed in this form, then we can find the sum of the series by simply evaluating from r equals 1 to n the sum of the f of r minus the f of r plus 1. Now that probably means absolutely nothing to you. When we go through and look at these series, which are often called telescoping series, we will see that it's fairly straightforward. We sub in starting from r equals 1, and then we build up a whole load that end up cancelling, leaving us either one term at the end and one at the beginning, or two at the end, two at the beginning. We add all of that up and we tidy it. So the take-home message, if you've got some finite series, which is expressed as u sub r, that can be written as the f of r minus the f of r plus 1, then the sum from r equals 1 to n of u sub r can be written as the sum from r equals 1 to n of f of r minus the f of r plus 1. Don't baffle yourself over this. It's fairly logical once we get going. So let's have a go at it. We're asked to express 1 over r plus 2 multiplied by r plus 3 in partial fractions. I'm assuming that you're cool with partial fractions. If you're not, check out the C4 videos. It won't hinder your ability to understand the next bit. It says, hence find the sum of the series from r equals 1 to n of 1 over r plus 2 multiplied by r plus 3 using the method of differences. So let's get some partial fractions going on. So we'll start with now 1 over r plus 2, and we're multiplying that by r plus 3. We can set up an identity now and write a over r plus 2 plus b over r plus 3. If we multiply through by the denominator, we're going to get 1 is going to be now the same as r plus 3 multiplied by a plus b multiplied by r plus 2. So we can see ar plus br is equal to 0r, so we can say a plus b is equal to 0. We can see that 3a plus 2b is going to be equal to 1. So 3a plus 2b is equal to 1. What I'm going to do now is multiply this by 2 and write it as 2a plus 2b is equal to 0 and subtract down. So that's going to leave me a, this is going to end up leaving me 0, and this is going to end up leaving me 1. So a is going to be 1, b is going to be minus 1. So we can express 1 over r plus 2, r plus 3 in partial fractions as 1 over r plus 2 minus 1 over r plus 3. And this fits in nicely to what we were looking at before. So this right here is now in partial fractions. And if we go back to the definition, whilst I don't believe in dwelling on the definition, this is what we're going to be trying to sum. We're trying to find and we could call this u sub r, and you can see that that can be expressed now as the f of r, which is this one, minus the f of r plus 1. So we'll go ahead and do that. So what we want to do then, we're going to sum this, and we're going to sum it from r equals 1 to n. So what we're looking at now is the sum of r plus 2 minus 1 over r plus 3. Okay, so that's what we're going to be doing. So what I'll do is I'll start with r is equal to 1. And I like to just build up a little table. So if we build up a little table here, let's put these on. Okay, let's now do this. In fact, we're going to need to probably extend these because I think I'm going to go a bit further down. Okay, so if we now look, what we're going to have is the following. This is going to give me now, if we take r equal to 1, okay, r equals 1. Subbing it in here, we're going to have 1 over 1 plus 2, which is going to be 1 over 3. Subbing it into that one, we're going to have minus 1 over 4. Okay, so this one right here is the r plus 2, and this one right here is going to be the minus 1 over r plus 3. If we now take the next one, we'll take r equal to 2. And of course, you don't have to do this as you go on, it'll be fairly straightforward. We're going to get 1 over 2 plus 2, which is 1 over 4. And then we're going to get now 1 over 2 plus 3, which is going to give us that minus 1 over 5. I think you can see what's going to be coming up now. This is going to give us 1 over 5. And then we sub in 3, we're going to get minus 1 over 6. What you'll start seeing now is a pattern emerging. And the pattern is going up from left to top right, if that makes sense. If not, I'll show you. That one and that one are going to cancel. When we add these are going to cancel out. A quarter minus a quarter is nothing. A fifth minus a fifth is nothing. And I don't know why I didn't put 3 just there, but you know what's going to happen when we go for r is equal to 4. Okay, so r is equal to 4. What we're going to get now is, in here, we're going to get 1 over 6 minus 1 over 7. And this one's working out quite nicely. And we're going to go right the way. Remember, we're summing from r equals 1 to n. So, although we don't need them, what I'm going to just show you now is if we have r is equal to n minus 2. Okay, what we'll have then is the following. We'll have now 1 over, if r is n minus 2, n minus 2 plus 2 is going to give us 1 over n. And then what we're going to have is 1 over n plus 1. And we need to subtract that. Okay, don't want any updates, get rid of those. So there we go. All I've done is that one. Now, if we set r equal to n minus 1, you can see that we're going to get closer and closer to this value of n. So, setting it up, what I'm going to have now is 1 over n plus 1. And then on this one, we're going to have 1 over n plus 2. And of course, we're going to be subtracting that. And then finally, what we'll have here is the following. We'll have r equal to n, which is going to be our final term. And then, as you can see in this one isn't relevant. We're going to have 1 over, and this is going to give us our n plus 2. And then we're going to have over here minus 1 over n plus 3. As you can see, what we're now going to do, when we add this together, remember, we're summing now this right here. So when we add this together, let's add it all up. This one and this one are going to cancel. That makes sense. That one and that one are going to cancel. That makes sense. A fifth minus a fifth goes. A 6 minus a 6. And you know that 1/7 is the next one coming up. And you can see this is going to happen right the way down. 1 over n plus 1 minus 1 over n plus that one. That one is going to go with the one above. That one will go with that one. And we're left now with the following scenario. We've got 1/3 minus 1 over n plus 3. So our whole series has collapsed to give us the first term of the third minus the last term. So what we can do now, we can say the sum from r equals 1 to n of our original, which is going to be now, if we look at it, this was the original, 1 over r plus 2. And then now r plus 3 gives us, and we'll just make that clear, it gives us 1/3 minus, let's put it here, 1/3 minus 1 over the quantity n plus 3. All that's left to do is combine this fraction. So the common denominator will be 3n plus 3. And on top, we will get now n plus 3. And then on this side, we can have minus 3, which leads us now to our final answer of n over 3n plus 3. So the sum from r equals 1 to n of 1 over r plus 2, r plus 3 is given as n over 3, the quantity n plus 3, by the method of differences. Please note that that really is a long way round. When you go into this in the subsequent videos, we're just going to go straight at it. We split it into partial fractions if required. If not, we'll just go straight at it. We set up this table, evaluate 1. We go down and see when they start cancelling off. Sometimes we'll need the n minus 2 and we'll be left with 2 terms at the bottom and 2 terms at the top. We collect them up, add them up, and then tidy at the end. All of the rest is all fluff, really. But hopefully that gives you some idea of what you're doing. And as stated, in the subsequent videos, we'll go at it with a bit more pace.